recording. Okay, so let's talk about this again. I'm going to zoom in here a little bit. Like that. In this problem, they asked us to find the coordinates of O. We knew the coordinates of O because they're on the x-axis. So the y value is going to stay 0. So it's going to be 0 here at the y value. The question is how far from the origin, from the y-axis, how far over do we need to go? Well, we can look and say this leg here, this segment here, is congruent to that segment. This segment went negative 3a units, so this segment over here has to go positive 3a units, right? So the answer has to be 3a, 0. And then from the work we did yesterday and reviewed this morning, I'm going to just mark my other answers here. Okay, and now we're going to work on this problem number 5 here. To do that, this one's going to be a little bit trickier. It's more like that problem number 3 that we looked at a minute ago. Okay, and we've got to work through this, so make sure my studio is picking this up. It is not, and not yet, but I'm going to get it right now. There we go. Looks good, okay? All right, so going back here. So what I've got now, I got to figure out what are the coordinates of n. They're asking me what are the coordinates of n right here, right? Right there, n. So what I know is, I know that it's on the y-axis, right? That vertex is on the y-axis. So what that tells me is that the x value, right, is not positive or negative. The x value is at 0. So now the only question is it going to be this answer or is it going to be that answer? All right. Well, what I have is I have a right triangle again. So I'm going to draw my right triangle out like this. Okay. And I know this is 3a units across. And then I know, now you got to use some thinking here. You got to use some critical thinking skills. I know that this entire distance is 3a in here on this side, 3a, and then 3a over here on that side. So the whole distance is 6a, right? And what else do I know? Wait a minute now. We don't know that this is I assumed they wanted us to think this was an isosceles or an equilateral triangle. So I was thinking for a minute this would be 6a units across, but they haven't really said that. We don't know that. So I got to think for a minute here. So help me think. Let's see. Where'd my eraser go? I'm gonna erase some of this mess. All right. What do I know? Let's go back, and my original first thought for how I would solve this problem, it's not working so well, and I got to think about how I can figure out that second thought. Oh, I think I do know. And this is a good kind of a thing to think about. So there's a distractor in here, right here. I know my answers. I'm looking at my answer choices, right? The only two that matter to me are these two, because I know the n is sitting on the origin and that the value for x must be 0. So these are the only ones. Now, what we have a distractor, and it's telling me, oh, it could be 3a units up. But wait a minute. That's saying negative 3a. If a was a negative value, the only way for this to be negative 3 times, so let's think about this, right? Negative 3 times a would have to be some positive number for n to be up above the x-axis, right? And therefore, x, if I divide it by negative 3, divide by negative 3, then whatever this value is, a would have to become negative, right? If this is some positive number, it would have to become negative. So a would have to be negative, but that can't be, because negative 3 times a over here is a negative value. So therefore, I know negative 3 times a, this answer right here, this is a negative value. And if I found that negative value, it would not be above the x-axis. It would be down here below the x-axis. So I can rule that problem out. More important, though, it's good to be able to answer questions by ruling things out or using logic or whatever. But what were they hoping for us to know here, really? Not just what test-taking strategy works. What were they hoping us to know? They were hoping us to know that we actually can't figure out how tall this is. We don't know how tall this is. All right? When we don't know, what we do is we use another letter. And we're using B. It is some value that is unknown. So that has got to be our coordinate that we would use. They're wanting us to know. See, if we've only been using A here and A there, and we don't have B defined anywhere, then this unknown value up here, right, how high or tall this triangle is, that unknown value is just B. So 0, B is the coordinates of N, right? Whew, that's kind of a good one. I will say that. Close that guy out. Go back to my answer key over here, and hopefully you don't have any problems like we did. So I think that is the final review. Let's see, we got our answer for 1. We got our answer for 2. We got our answer for 3. We got our answer for 4, and we got our answer for 5. So I'm going to go ahead and grade the quiz. Yay, we got them all right. That feels good, right? All right. So I'm going to close that out. And remember, this is work you can be doing at home. You're preparing for a test. You can do this at home, but you're just choosing to do it with me. Now we get down here. We've been through all these lessons. We're going to review and assess this chapter together. We've got 2 checks here, right? We've got a check of a chapter test, and then we have a check that is standardized testing. Okay? So let's do the standardized test first. It says, which pair of triangles are congruent by the side postulate? Okay, I don't even know if I want to do this one. I'll be really honest with you. This is a terrible, terrible kind of a question for this format. And I'm not sure I would really ever vote for this kind of a question either. I'm just really honest. If I was writing a test, I would not write a question like this. And the reason is, all they're really asking you to do is do the distance formula over and over and over and over and over again. Well, let's just talk about what SSS is, and we understand this question. Make sure we understand it. Okay, so we'll do this. And let's make sure we understand what it's saying. Okay. All right. So right here in a second, you're going to have this screen come up. So while we're waiting for this to come up, there it is. So what we're waiting for is, or what we're thinking about is that this says side, side, side. So, or SSS, and SSS means side, side, side. So what we're talking about here is we're talking about that we would have the sides, the corresponding sides match. Maybe I'll use a different color for this. Let's see if I get an eraser, and let's just do, we have 3 sides here, right? We have this side, this yellow side. We have this green side here, right? And then we have this blue side right there. So we have 3 sides, right? So what are the sides that correspond green, yellow, and blue? All right, so the yellow side, the first side, we could call A. Oops, that's not the yellow. Hold on. So let's go with our third side, right? Our third side would be, maybe we would call that BC. That has to match EF, right? Oops. And the middle side would be what? Oh boy, Mr. T. What am I thinking? Let's try this one more time. So I should start with the first. Let's start with the first and just don't make a mistake. I just made a mistake with you guys. All right, the first side they're talking about, I'm going to call that AB. and that should match to DE, right? And then the second side would be the middle side, which would be BC and EF, right? And then the third side would be F back to D, C back to A, like that. So those are my three sides. Those are the letters I would use. So if I was writing this out, so I would say AB has to be equal to the yellow, right? That would be DE. And BC, it would have to be equal to EF, right? And then we would go back A to C. Right? A to C, see the blue, is equal to D to F. So what I have to do for just to test A is I have to do the distance formula, let's see, 1, 2, 3, 4, 5, 6 times. So I'm just doing the distance formula 6 separate times for one problem that may or may not be right. And what I need to do is I've got to check this one 6 times, and I got to check this one 6 times. And I got to check this one 6 times. So they're asking me to do the distance formula 24 times. If I've made a mistake on the correct answer, I'm not going to recognize it as a correct answer. So then I might have to go back and check everything again. I don't get any correct ones, so I got to go check again. So it's kind of a mess. I don't prefer this. I'm going to check this guy, and I'll tell you why I'm going to check this one. Okay? I don't want to do all of them, but what I like about this one is at least what do I see here? In fact, let me get my highlighter here and highlight this right here for you. This point was chosen very wisely, and same with this one, and same with that one, because it's at the origin. It's at the origin, and this point right here is on the x-axis 3 units to the left, and this point is on the y-axis 7 units up from that origin. So if I'm looking at a triangle ABC, this one's easy to see. It looks like this. There's the x-axis, there's my y-axis. So I've got B is over here, A is up here, 7 units up, A, 7, 0, right? And then C would be over here, negative 3 units over, that'd be C. So that's a nice choice. So doing my distance formula anyway is going to be easier on this one. So I'll do this triangle. I'll do AB, BC, AC, and then I'll just do DE, EF, and DF. And I'll do all that work just so we can see if A is correct. And if A is, great. And if not, I'm not going to do it for every other one. It's just not a good use of your time right now, in my opinion. Because you see how to do them, and then you should know how to do them yourself. All right, I'm going to go ahead and do the distance formula. So remember, distance formula, we always write it out. So we write the distance formula out as something that you're supposed to memorize, but we should really understand what it is. Let me get my eraser here. Sorry, just erase some of this stuff here. It's a little noisy. All right. So whenever we say, oh, the distance is equal to, this is the way it's formally written all the time, right? What we do is we say x of b minus, this is the distance of a, b, right? So we say x of b minus the x of a squared plus the y of b minus the y of a squared, right? So just that's fine. That's what it is. What we should probably do, and what we really need to be teaching, I think, and so do most people at this point, we should be understanding that when we're talking about the distance between any 2 points, gosh, I gotta get better at this. All right, I'm sorry, stick with me. I'm talking about the distance between any 2 points, let's say this point here and this point here, that to solve that distance, right? What I'm thinking about is forming a right triangle, and that this is my vertical distance, right? This is my vertical distance, that leg, right? And we call that in college algebra, we use this symbol, the triangle symbol, which means delta, and delta represents change. So delta y is my vertical distance, and And this over here is my horizontal distance, right? Like the horizon. So this is my horizontal distance. And so we call that delta x, right? So essentially what we're trying to do is find out how much x change was there and how much y change was there for any 2 points. And then if we know that, then we consider this a right triangle. We can use a Pythagorean theorem to figure it out. This leg here and this leg here, if I square it and I square it, then I can know it's going to be equal to the square of my hypotenuse, right? So to find out this distance here, I just square this leg. Let me write that out. So if I want to know the distance of the hypotenuse, I know that square of that is going to be equal to the square of the leg plus the square of the other leg. So try this again. The hypotenuse squared is equal to the square of delta x, right? Whatever that horizontal change is, plus the square of delta y, whatever the vertical change is, right? And so now if I want to solve for this h, I take the square root of both sides. So let me do that with the color here. So I'd take a square root of this side and I'd take a square root of that side. And then once I got done, I could write, well, then my horizontal distance, or then my hypotenuse, which is my distance here, is equal to, the square root of the square of the horizontal change plus the square of the vertical change, right? So last thing I need to do here, say the hypotenuse is equal to, and how do I find horizontal change? Well, like if you had a ruler or something, right, you would check the measurement here, you'd check the measurement here, you would subtract between them to find the distance, or the difference, right? So this could be written as x minus x squared, and then y minus y squared. That's our intuition for distance formula there. So I'm just looking at subtracting my x's, subtracting my y's, squaring them, okay, really, and then add them together and take the square root, and the whole thing comes, now you see where the whole thing comes from. Well, here we go, let's do it for this problem. Now I'll erase the whole thing. So here we go. We're going to go back here. So AB, so I'm going to go to the square root. So AB, I'll write AB equals, right? It's kind of messy, but I'm going to go with x minus x, which is 0 minus 0 squared, plus y minus y, which is 7 minus 0 squared, right? So this is 0 squared is 0, plus this whole thing just going to go away, right? So really, we're just looking at 7 minus 0, and 7 minus 0 is 7, and that's 7 squared, and that's equal to the square root of 49, which is equal to 7, right? That's going to cancel these guys out, right? So 7 is my answer for AB. So remember a minute ago I said, oh, we have to do everything. No, actually, now that I think about it, I don't need to do all 6 measurements, right? I just have to test to see if the first one is true, because if it's not true, if AB does not equal DE, do I need to check the rest of them? The answer is no. So I only continue my checks, B, C, and EF, or whatever, if AB is equal to DE. So, and I'll tell you right now it is, but I can just see that in my head. I'll explain why in a minute. All right, so here we go. Let's go with a different color for this leg here. Okay, so I'm looking at DE, right? So, oh boy. Let my fingers drag across the screen. Here we go. So I'm going to go with square root of, right, 5 minus negative 2, 5 minus a negative 2 squared, plus 5 minus 5, right, 5. Do you see why I could just look at it and know? Right, I immediately see here, oh, these are both on the line y equals 5, right, and they're just 5 and 2 units apart. So 5 minus negative 2 is the same thing as 5 plus 2, so this is 7 squared. and this is 0 squared, right? And that's all going to work out to, right, 49, and then take the square root and we get 7. So this is also 7, so that's good. So we can see that AB equals DE. All right, now let's check BC. Okay, so for BC, and I'm sorry my handwriting's so sloppy. It is kind of hard because I'm on this written screen here, and it is not easy right now. All right, let me get going on this thing here. So I'm going to check BC. BC is also easy. In fact, I don't even need to check this, right? I know that B is at the origin. B is right here. And C is -3 units over. So that's if this is -3, then the distance here, this is 3 units. So BC equals 3. I'm just going to write that. All right. When you're doing tests, you don't want to make mistakes, but you do need to save time sometimes. You got to think through things like that. So I'm going to check, is this one also equal to 3? Well, I can see that x equals -2 and x equals -2. So essentially, E, let's plot these out and you can just see this. E is at -2, +5. So -2, 5, right? Where's F? -2, -2. So my intuition, I don't have to use my distance formula there. I can see I'm 5 units and 2 more. This is 7 units apart. Whereas BC is only 3 units apart. EF is 7 units apart. Therefore, that can't be a right answer. All right, that's enough time on this kind of a problem. I think you'd have to keep going through. So we can rule out A, but you got to use your logic to rule out the rest of them. And using distance formula, you can graph. You see, I use a lot of different strategies here. I graphed some things out right here just to kind of see it, right? I used my distance formula, and I just made sure I understood what I'm testing for. Are the corresponding sides congruent? And they have to be, okay? So in this case, they were not. So close that guy out. And let's keep going. I don't have any calls right now. All right, so this one is, what is the equation of the line that's perpendicular to the line that has K? All right, this is good. So we're going to have to find the slope. We know that a line that is going to have a perpendicular slope to it. So let me get over here. You know, this one actually is not part of this unit. Now I look at this. Yeah, you know what? We've got some things here on this test. Yeah, we got things on this test that are, some of them are from this unit and some of them are not. Like rotational symmetry, we're not. So this standardized test, it's kind of a big review. I'm gonna close that out. We said we have 2 types of tests here: a standardized test practice, and we have a chapter test. And right now I'm just worried. I want you to practice the chapter test, not the cumulative test. And you know, we only have another 50 minutes here. You can practice the cumulative test all you want. And I encourage you to do that. But we're going to, together in here, let's just do this, the unit test. So what is the correct order of the following statements and reasons should be used to prove that that's a funny symbol, but it should be triangle KLN is congruent to triangle MLN. So KLN and MLN, right? So how can I prove that? Well, the first thing it says that LN is congruent to itself by the reflexive property. So that's going to be true. So let me do this one more time, and I apologize about this, right? Because I know this is like a drag that requires okay. So let's write out whether or not things are true. Well, they're all going to be true. I know that. But let's write out whether or not they are dependent on something else. Can I just state anytime I want that ln is congruent to ln? And my answer here is this can be done anytime because this is just a property of congruence. So I can put that one could be the first thing I state, it could be the last thing I state. Excuse me. I'm sorry. It would not likely be the last thing I state because I'm trying to prove something with it. I'm going to use it as something I'm going to prove with it. So I'm going to move this and expect that it's going to be used probably either here or here. It's not going to be like one of the last things I use, but who knows? But I can really state that anytime. And here it says right angles are congruent. Well, that's true, but what we don't know yet, have we for sure. See, I want to make a state about the property. This is a statement about the properties, right? So there's the properties of right angles, right? Right angles, right? And before I can make a statement about the properties, I have to make a statement, right, that they are right angles. Aha. I have to make a statement that they are right angles. Right? So this is the statement about the object itself, right? That they are right angles, and then the properties, those right angles are congruent, right? So I'm making a statement about an object in this case before I make a statement. So 6 has to come before 2. So things I know, I would say, things that I know here include that 6 comes before 2. Well, that would rule out these two guys, right? I'm not going to say they're congruent before I say that they are right angles, right? Especially because you're not going to say they're congruent because they are right angles. So now the question becomes, is it A or D? Now let's keep going. 3 says the definition of congruent polygons. Well, guess what? That is what we're supposed to end up with here. So 3 should be last. So this one should be last. So 3 is last, right? So that's something else I know, right? So I knew this, and now I also know 3 is last. That doesn't help me, though, because check it out. 3 is last over there. What about this one? Aha, this is the given statement. And usually the given statement, we can write anything. We usually start with that, so that should be first, right? So we know that 4 has to be first. 4 is first. Well, guess what? That didn't help me here either, right? Okay, so let's look at 5. 5 says that the angles are congruent. Oh, the angles are congruent. So 5 is saying the angles are congruent. So, and it's saying it by the third angles theorem. So this number 5 is a big deal, okay? Because what is the third angles theorem? Well, let me get another color here and kind of remind you about the third angles theorem. Okay. So third angles theorem says if I have two triangles, right? Right? If this angle right here and this angle right here are congruent, right? And then if this angle right here and this angle right here are congruent, right? What the third angle theorem, the term third angle theorem that they're referring to is not used universally that I know of, but what they're referring to is that the third angle must be congruent. So if they're using this third angles theorem, what they're telling you is they're saying you would have to, before you could use this, you would have to prove that the green angles are congruent and that the yellow angles are congruent. Right? Until you've proven that the green angles are congruent and the yellow angles are congruent, you can't prove that the red angles are congruent, right? You can't use the third angles theorem. So 5 is going to have to be after. Let's go back here. So 5 is after Now, which are the ones that tell me my angles are congruent? Right here. This one right here. So it's after 2, right? And where's another one where we say that angles are congruent? The right angles. So where's the, oh, and then this is in, okay, so 5 just has to be coming after 2 because we know that these angles are congruent on their own because of the diagram. And in fact, that was given right here. So 5 comes after 2. So when I look here, I see in this case 5 is coming before 2. I can't use the third angle theorem until after I prove that the second angles are congruent. Does that make sense? So this cannot be. Here I'm going to prove that the second angles are congruent, and then I can say, oh, well, then the third angles have to be congruent using the third angle theorem. So D has to be my answer. D has to be my answer. Okay, good one. That's a good problem there. Have to look and think quite a bit. I kind of like that problem. Okay, I know some of you guys don't. Uh-oh, I got problems again. All right, here we go. Scrolling around here. But it's not going to let me click it. That's okay. Which pair of triangles is congruent by SAS? SAS is side, angle, side. So I think we can zoom in on this one and just see. Ooh, having the same problem with my keyboard. It does not look like it's responding to me anymore here. So let's try just looking at it like this. Side, angle, side. So this one I see this side is congruent, like PQ is congruent to RS. Right? This angle Q is congruent to angle S, and QR is congruent to ST, or 1. I think that's supposed to be a T. So this side, side, angle, angle, side, side, these guys seem to match up. So I think that one's definitely a good answer. This one has angle, side, side. Uh-oh, we know that's naughty. We're not going to do that in my classroom. No ASS, right? So that's not it. This one is side, side, side. 5, 5, and 6 matches 5, 5, and 6. So this would be side, side, side. And this is angle, side, angle. Angle, side, angle. So the only one that was side, angle, side, what they're asking me about side, angle, side would be A. Let's take a look at 3. What is the measure of angle W if the measure of angle X is 59 and the measure of angle XYZ is 137. Okay, this is really good. I like this problem. So let's get this going here and see if I can get my studio to pick that up. There we go. All right, I'm going to draw this a little bit bigger here. I'm having problems with zooming, or I just zoom it in. But I basically have a triangle that looks like this, right? And they want to know what the measure of W is, which is this angle right here, right? They want to know what is W. What we do know is that X is 59. This is 59. And then it says XYZ, XYZ. So this angle here is 137. All right. So now, if I think about this angle in here, right, and that one together, they're el pipi. The linear pair postulate tells me these two, they're a linear pair, and the linear pair postulate tells me that what we have is we have supplementary angles. So I know these equal 180 together, right? So if I take away the 137, and what I'm left with is this red angle here, right? This red angle here is the only thing that will be left if I take the 180 and I subtract that, right? So now that helped me figure out this angle here. So let's do that. So let's see. I borrow. I don't know if however you guys do your arithmetic is fine. 17. Okay, so we have 43. So this is a 43-degree angle. So what else do I know here? Well, I know that these three together have to sum to 180 by triangle sum theorem, right? So if I say, let's go with another different color here. So if I said 43 plus 59 plus W, that has to equal 180 also, right? So now all of a sudden you start saying, wait a minute. If 137 plus 43 equals 180, right? So this sentence, that sentence, they're two math sentences or two math equations. They're equal. They both equal the same thing. That means this thing has to be equal to this thing, right? I'd write 43 plus 59 has to be equal to 137 plus 43. Oops, plus W. I forgot. Oh, that's a big deal. Don't miss that, right? 43 plus 59 plus W has to be equal to 137 plus 43. And if I get rid of now, if I subtract the 43 from both sides, right, then I've got W plus 59 equals 137. Now I can subtract my 59 from both sides and find out what W is. So 137 minus 59, right? So I'd borrow here and make that 12. 17 minus 9 is 8. 12 minus 5 is 7. 78. This has to be 78. So now this is sometimes called it depends on the publisher you look at. But this theorem, this is what we just reasoned our way through here, right? This whole thing we just reasoned our way through is sometimes called the remote exterior or remote angles theorem, okay? And remote interior or exterior remote interior angles theorem. They have different ways of saying it, but it's often referred to as something like that. The remote interior angles theorem. So the point is, this is an exterior angle here, right? This one. And these two are remote to it. That one's adjacent to it. Remote means far away, right? Like you hold a remote control, you don't have to go up and actually touch the TV. You can just point and aim and click. So adjacent means next to, and these are the remotes. So what we're saying is an exterior angle of a triangle like this guy has to be equal to these two together. Okay? So if you know that theorem, then you just instantly look at this problem and say 137 minus 59, that'll be W. This minus that will give me theta, W. So the answer was 78. Okay? All right, that's the reason why. Together, right? Together these form linear pair. Linear pair by LPP is the linear pair postulate is supplementary, so equal 180. These three together by the triangle sum theorem, these three equal 180. So therefore, if I take away this adjacent interior angle from each of those equations, I see the remote interior angles are going to be equal to the exterior angle every time. That's that theorem there. Okay, we'll close that guy out. Ooh, boy. Close it out. Hide that drawing tool. Here we go. Okay, we have what are the coordinates of n? What are the coordinates of n? All right, man, I got to find a way to zoom this in. Oh, good, it's working again. All right, what are the coordinates of n? All right, so what do I know? Well, we did this one already. This is the same problem we had before. We had 3a units this direction, 3a units that direction. And then if I go up, I don't know how many units up that's going to be. I don't know how many, so I would just say that I know that x value is 0 because n is on the y-axis. It's not to the right of the y-axis, not to the left. It's on the y-axis, so the x value is 0. And then I don't know how many units up it is, so I use b. So this one's going to be b. I can mark the rest of these. What did we have here? We had, this one was D. We had what? We had this one as A. And then we had this one was 78. Okay, let's go take a look at number 5. Isosceles triangle with, okay, let's do this guy. Here we go. Okay, sorry about that. We have an isosceles triangle. Okay. Get into my studio and bring this where my drawing tools up. Okay. All right. So I'm going to draw out a isosceles triangle ABC, and I see that AC is the base. So that means I'm going to have a triangle that looks something like this, right? And just to make it simple, I'll put A here and C there and B up here. If AC is the base, then the legs are AB and BC. And because it's isosceles, then they are congruent, right? That means I also know the angles opposite the legs, right? Or the base angles, we call it the base angle theorem. These two have to be congruent to each other as well. So this angle we're going to call 3x plus 9, right? Measure of angle A. And this angle here is 5x minus 13, 5x minus 13. They want us to figure out what is the measure of B. Well, what do I know? I know these two are equal to each other, so I'd write out an equation. 3x plus 9 is equal to 5x minus 13. I like to move the lesser all the time, so I take away 3x from both sides, and I'll add 13 to both sides, right? So that's subtraction property of equality, of equations and of equality, yeah, and then this is the addition property of equality. So when I simplify, that becomes just 9 plus 13 is 22, and then this cancels, right? And then I have 5x take away 3x is equal to 2x. And now I divide by 2, division property of equality, and I get x equals 11. So what I know is x equals 11. If I plug that in here, oh boy. I don't know how I moved that guy over some. Oops. Well, that's all right. 3 times 11 plus 9, I get 33 plus 9, which is equal to 42. If this is 42, this is also 42. So together, they're 84. All right, so this is 84. How am I going to figure out this last part up here? Think about that for a minute. These two are 84. So how am I going to get that last one figured out? Together, they should form, what, 180? So if this is, we'll call that B, right? So I know 84 plus B equals 180, right? I take away the 84 from both sides. Get B equals 96. Boy, some kids would just pick B because that's one right there, right? I'm kind of that way myself sometimes. B equals 96. In the diagram, triangle LMN is congruent to triangle RST. Find the values of x and y. Ah, interesting. So LMN. Oh, I like this one too. Let's get this guy going here. Sorry about that. Get my studio caught up. Okay, there we go. So the key is to remember corresponding sides LM and RS. So LM is this side and RS is this side, right? That means angle N, it corresponds to angle T, right? Then getting another color here. Let's go with, I don't know, it's purple. MN, right? MN corresponds to ST. So MN and ST correspond, right? So there's my first equation I can write, right? MN equals ST. So 2y minus x equals 20.8. I can't solve this right now because I just got a y and an x. But what else do I know? Well, I also know, let's go with this color here, that means NL, this side, corresponds to RT, or TR, right? So this side, right? So these two correspond, but it also means this angle corresponds to that angle. So I know that 98 is equal to 5y minus 7. So if I add 7 to both sides here, I get 5y is equal to 105, right? And if I divide by 5, I'd get y equals 21. Now that fact is useful. Now that if I know y equals 21, well, I'll get my eraser and make a little room in here. Oops. Y equals 21. Well, then if I go in here, solving for x is going to be easier because I can put the 21 right there. So 2 times 21 minus x equals 20.8. 2 times 21 is 42. Take away x equals 20.8. And if I add x to both sides, I get 42 is equal to 20.8 plus x. If I take away 20.8 from both sides, right, I get x over here all by itself, oh boy, is equal to, and then I'm going to have, what's that, 21.2. So I've got x is equal to 21.2. Is that right? 42, yeah, okay, yeah, that's right. Okay, so x is 21 or y is 21 and x is 21.2. Y is 21 and x is 21.2. Oh, did I get these backwards? I must have. I don't remember what I had written down. I closed it out, but one was 21, the other one was 21.2. I think, unless I made a mistake, I could have made a mistake. That happens too. Maybe you caught it. If you caught that mistake, give me a call and let me know what I did wrong. All right, here we go. What is the value of x? All right, so this is a triangle sum theorem one I see, and base angles theorem. So I got a couple of things to consider here. Okay, and it's kind of a cumbersome process, this thing here. I got to get faster at this. All right, so if I'm looking here, I know because these sides are congruent that I know these angles are congruent. So that's 58. This is also 58 degrees. And because of the triangle sum theorem, I know 58 plus 58 plus x equals 180, right? Add those together, I got 116 plus x equals 180. If I take away the 116, then I get x equals 64. Well, that one's not too bad. Okay. Next, triangle ABQ is congruent to triangle CBQ. ABQ is congruent to CBQ. How do we know that? Well, there's a couple of things I would look at here, right? I know that this angle here is, let me get some color. Oh, I don't have the drawing tool. I'm not going to get the drawing tool up. See this angle BQC is marked congruent to BQA. So these two angles are congruent to each other. And these two angles here are right angles, and all right angles are congruent. So these are congruent to each other, and these are congruent to each other. And then this leg is congruent to itself by the reflexive. So I have an angle, a side, and an angle. Right? I don't know. I could say angle, angle, angle. Wait a minute. That's not a congruence postulate. That's not a congruence postulate or theorem. So I'm not going to use that. And I don't have enough information about the sides other than just the one side being congruent to itself by the reflexive. But that's enough. So angle, side, angle it is. In the diagram of the bridge, oh boy, I remember doing this one before. The bridge deck is perpendicular to the cable. So we have, these are right angles here, right angle here. So this leg is, so we have two right triangles, right? And this leg is congruent to itself by the reflexive. And these angles are given as congruent. Therefore, these two triangles are congruent. Then by CPCTC, all the parts are congruent, right? So what's missing in the proof? Oh, look at this. given that the triangles are congruent, then also given that that's a perpendicular cable, BD, right? Then because of that fact that it's perpendicular, we know these are right angles here and here. All right, so statement 3. Here's the statement about the objects. They are perpendicular. Here's a statement about their properties. They're right angles, or let me get away from that for a minute. That's just going to confuse. Sorry to even confuse myself for a second. But let me go backwards on that and just say we know that they're perpendicular. Therefore, we know that they are right angles, right? Okay, so then we have perpendicular lines here, and then that means that they are right triangles, right? And this is congruent to itself by the reflexive property. So now how would we prove the two triangles are congruent? We have an angle and we have a leg. So it'd be leg angle. That's it. I went too far when I said CPCTC because we didn't have to go that far. All right, next. Which one is angle, side, angle? So angle, side, angle, just remember that means a side in between a pair of congruent angles. So here I have a side that is not in between the congruent angles. This is an angle, but no, I'm looking for a side in between congruent angles. So here's a side in between congruent angles. So there we have it. This is an angle in between congruent sides, and this is a side but not in between the congruent angles. And this one is also a side but not in between the congruent angles. So this is the one that has the side in between the congruent angles. So it's angle, side, angle. Okay? Are the pair of triangles congruent? If yes, choose the theorem or postulate that best applies. So I have right triangles, and I have the hypotenuse here and the hypotenuse there, and I have the angle here and the angle there. So yes, by hypotenuse angle. Okay, we just did this one before. That's a 4 foot by 5 foot, right? So we did that one earlier this morning. I'm not going to redo it again. All right, the remote interior angles. Ooh, good. I like this. Let's make sure, because we just barely started talking about this a little bit ago. I think it's good for us to actually, refresh this again. This concept of a remote interior angle is a good one, okay? So when I look at the remote interior angles of this triangle, or of this triangle and that particular angle BCD. So BCD, this is the exterior angle, right? So that's your exterior. So one angle inside is adjacent, and it's this one. That one's adjacent. So that means the other two that are not adjacent, they're the remote angles. That's this guy and this guy. Those are my remote angles. So what would be the names of those angles? You can name them a lot of different ways, unfortunately. But we're looking for something with CBA, either angle CBA, or it could be called angle ABC. That needs to be one of them, but the B is in the center here. CBA, it could be this guy or this one right here. Okay, and then this angle here is going to be called BAC. It could be called BAC, right? It could be called angle BAD, because I could go all the way out there to D. I could call it angle CAB, or I could call it maybe this way, right? Or DAB, angle DAB. They're all the same angle here. So this one has angle CAB and angle CBA, and those two are correct. That one has BAE. BAE would be this guy outside, BAE. So that one's not correct. Okay, and the one that has angle C, that one's not remote. That's adjacent. And this one just has BAE. Says these two, and BAE is not even interior, right? It's an exterior angle. We just got to remember this concept. Here's the exterior angle they gave us, BCD. That's the exterior. So these two this one's adjacent to it, right? So the other two angles are the remote interior angles. Okay, I like that we got a chance to go back over that again, because even when we were doing it a minute ago, I thought, have we spent much time on that? And I think some kids might not be that familiar with it. So, all All right, here's our last question. Might get to finish class a few minutes early this morning. It says triangle DEF is congruent to triangle DFG. DFG. All right, so how do we know that? Well, I have this side and this side correspond. This side and this side correspond and congruent, right? So corresponding congruent angles. And then this side, nothing else. I don't have any angles or anything, but I do see this side is a shared side, right? So therefore, it's a common side. It is congruent to itself, right? DF is congruent to itself, and that's so obvious to us, right? We would use the reflexive property to make that statement in a proof. But we know this third side is congruent to itself, so side, side, side is congruent to side, side, side. So we'll go side, side, side. Oh boy, let's hope I got it right. It says I missed one. I knew I must have made a mistake on that 21 and the 20.2. I made an error on that one, I'll bet. Where's the error? Right here. What? How did I miss this? C, A, B, and C. Oh, I just forgot to mark it. I was saying it, but I forgot to mark it. Okay. CAB is this one. We did have that one. And this one, we had that marked also. So I'm pretty sure that, this brings up a math practice, though, that I think is really important. One of the standards, if you're in a common core state, like we are, we call them Idaho core standards, but basically adopted from the common core standards. One of the standards is a practice standard, meaning it's not tied to any particular class or grade level. It's just in general something mathematicians should always do. And it deals with paying attention to details. Right? The practice standard talks about being attentive to details. And that means don't be sloppy in your work, right? Don't be sloppy. Here I am, I'm not getting 100 on my test. I should have got 100 on this. I got a 93. Okay? Why did I not get 100? Well, it's not because I didn't know the answer. It's not because I didn't do the work. It's because I got sloppy with my details and I didn't even mark the answer that I knew was correct. I marked it on my drawing paper. I forgot to mark it on my bubble sheet. So these things happen to kids all the time. So don't forget that standard. Be attentive to details, okay? Just like I need to be. It will boost your grades. And I'm just going to tell you, sometimes that little boost in your grades, it's the difference between you getting into a school or not getting into a school in college, right? Or when you get to college, if you're going to community college, a lot of times they're going to want to have you take a math test to prove what you know. And I've had kids drop out of college altogether because after taking that test, like a test, they call it a compass test or something like that, after they do that intake test, they get told, oh, you have to take remedial math. And those poor math students, now they have to take high school level math again. And the worst part is, because it's remedial and because it's high school, your college grants, like your Pell Grant or whatever, won't pay for it. So kids have to pay for it themselves. And that's sometimes a burden that's too big to bear. So kids sometimes drop out at that point. I don't want that to be the case with any of you guys. And I feel really bad because I think to myself, oh, they're good mathematicians. They already knew the answer. The only thing they didn't do was they didn't mark it. And then I think to myself, well, actually, that's an important part of being a mathematician too. That's why it's one of our standards here. So that we say, we are teaching to you guys all the time, from the time you're in kindergarten to the time you're finishing high school, so that you're ready for college. We're teaching you pay attention to details. And when you get something wrong, like I did right now, I got this wrong. I deserve to get it wrong because I'm moving fast and not paying attention to details. Okay? Don't want to make an excuse for myself. Okay, I should have got 100 on this. All right. Well, we had an interesting call-in period today. All right, we had somebody calling in and asking about Big Macs. We had some different callers, but class is done. I'm not going to do any more with this right now. What we'll do, let's talk about schedule for tomorrow going forward. Tomorrow starts spring break. Congratulations, the 21st of March. Doesn't seem like it could get here soon enough for us, right? So congratulations on making it to spring break. And what I'm going to say to you now is be safe and enjoy your break. Give your time to your family. If you have family nearby, pay attention to them and try to enjoy. Get out. I don't want you to get out and socialize, but if you can go out in the outdoors for a minute and just breathe fresh air, maybe go for a walk. If it's not in your community, I don't want you to go for a walk around people, but just get your head good, because this is hard times that we're living in. We will come back. Right now, we're scheduled for class to continue on March 30th, which is a week from Monday. And I will be doing this exact same thing unless they ask me to stop. If they tell us that they're postponing school altogether and they're just putting everything on hold, then I will stop. I'll do what they ask me to do. Okay. If they tell us that that's not the case, well then I'm gonna be right here streaming again on the 30th of March, and I'll use Google Classroom to send you guys the link. Okay, and you guys can count on me being there for you to help you. Okay, I want to make sure that you get the chance to. Oops. Sorry. I want to get you the chance to. Sorry, I just started resizing that. Okay. I want to give you the chance to give me a call and to keep working on your math and to keep making progress towards graduation. So I will be picking right back up. We'll do some more stuff for lift. For those of you worrying about geometry B, we want to keep making progress, okay? But just give me a call, okay? You can call me at this number. And if you have any questions or need any help, I'm going to be taking a break now. 12:30. I'm going to be starting a new chat. I'll upload this video here in a minute, and then we will start a chat for STEM Academy, and then after STEM Academy, I will be going on break myself. So take care, love y'all, and I'm glad you stopped in, and I'll talk to you soon.